Hello everyone, as a part of the CSCI-E-90 Final Project, I have built a system to capture malicious URLs and harvest the data for further analysis. Let's take a look at the project overview. This system is highly scalable and could be used to harvest malicious URLs from various sources of internet feed and make them available for further research. As of now, the solution is completely based off of AWS suite of products and could be expanded to include other cloud-based products from different vendors. As a part of the part 1, we'll be capturing the data from internet feed through AWS Lambda function, which is triggered through EventBridge. The data is extracted from the web pages. It is transformed to suit our solution, and the extracted transformed data is then loaded to the database. The database is hosted on AWS RDS MySQL system. The Lambda function is scheduled through EventBridge using a cron job, and the Lambda function will automatically generate CloudWatch logs for further analysis. As a part of the part 2, the REST service endpoints are built to help query the system and check if the given URL is a good URL or a bad URL. Let's take a look at the system design and process flow. Under part 1, the Lambda function acts as the ETL tool that will capture the data from the internet feed, transform the information, and load the finalized content to the database. The EventBridge, in our case here, acts as the scheduler that will trigger the Lambda function once every minute. The Lambda function also generates CloudWatch logs for us to help monitor the process and identify any error messages if something should happen. Under part 2, the clients or users can access the system and query the information through AWS Load Balancer. The load balancer accepts the client request, will delegate that through target group 2A EC2 which hosts the REST services. The REST service has two endpoints right now. One is the check URL and the second is check domain. Both these endpoints will help us to query the system either through a URL or through a domain to identify if a given input is a malicious URL or a good URL. Let's take a look at the Lambda function and the EventBridge trigger. We have load fish tank data Lambda function that's running on Python 3.11 environment. We have PyMySQL, Beautiful Soup, Fake User Agent, and Charset Normalizer as dependency layers that will help run the Lambda function. The EventBridge trigger is set to execute the Lambda function once every minute using a cron pattern. The Lambda function will automatically generate CloudWatch logs for us to monitor the process and status and identify if there are any errors. In our situation, currently we'll be using Fishtank as our internet feed to capture malicious URLs. The screenshot here shows us the load Fishtank data Lambda function. The Lambda function generates the logs whenever it is being executed. The trigger for this one is the EventBridge trigger that will be executed once every minute. And we have Fishtank website that is our source for the internet feed. Let's take a look at the AWS MySQL database. The MySQL database is used to store the data that is being captured from the Lambda function. The Lambda function takes care of saving the data to the database automatically whenever it executes. URL_hash is one of the fields that is automatically generated by the database depending on the URL field value. The field is indexed for unique search and fast data response. URL_ID is a uniquely automatically generated value. It increments automatically and is set to run as a big int type. This helps for easy scalability. Is_malicious field, which is a tiny int which signifies whether the URL is a malicious URL or a good URL. URL_domain field is also indexed, which will help us search the database through domain values. The screenshot here shows us the basic query to look at the data in the table. These are the sample queries that could be used to run on the database table. And the screenshot here shows us the columns that are available under the URL table. The database name is CSCI-E-90. Let's take a look at the load balancer and EC2. The AWS load balancer, which is the application load balancer, in our case, will help interact with clients and users to accept requests and send responses. The requests are sent to the target group, which are then forwarded to the EC2, which hosts the REST service. The REST service is based on Python programming language and Flask API framework, which is known for developing REST services with minimal dependencies. We have two endpoints right now. One is check URL, which is used to check a specific URL for if it is a malicious or not. We also have check domain, which helps check for a URL through domain name. We are using gUnicorn to provide HTTP server capabilities for our project. The REST service sends 200 HTTP status codes for valid responses and 500 for invalid responses. Let's take a look at the demonstration of the project. Under part 1, we have load fish tank data Lambda function, which acts as the ETL process in our project. The Lambda function reaches out to the internet. In our case, it is the fish tank website to scrape the data off of the web pages. It will use the beautiful soup dependency package to scrape the data and use the PyMySQL database package to save the finalized data to the database. Below is the source code of the Lambda function and the dependencies. The Lambda function is triggered once every minute using event bridge, and event bridge is scheduled to run once every minute using a cron expression. Whenever the Lambda function executes, it generates series of logs under CloudWatch. Here on the screen, we can see the Lambda function log files. Let's take a look at the Lambda function log file here. As you can see, it generates the URL domain and its hash value, and whether it has been successfully added to the database. In our situation here, all the records have been inserted successfully to the database. Let's take a look at the AWS RDS MySQL database. Here on the left pane, I have the database list. For our final project, I have CSCI-E-90 DB cluster, and this cluster hosts the database. The database name is CSCI-E-90, and it's a t3.large class. In the right pane here, I have set up dbeaver, a third-party client to interact with the database, and I have sample SQL queries to run against the database just to show that the database is active and it has content in it. We can take a look at the total number of records right now. We have around 2000 records. Let's check for google.com as one of the domains. We have one record that says google.com is a domain and a URL associated with it, and it is not malicious. Let's take a look at the load balancer. I have one load balancer that is created here for the final project, and this load balancer is configured to work on HTTP port 80. We have two rules configured underneath it. One for the default rule that will send 404 response for anything that doesn't match the pattern that we have here. For the pattern that we have here, that will be URLs. If the requests match this pattern, the request will be forwarded to this target group FIN. The FIN target group has one EC2 machine linked to it, and this EC2 machine forwards the request to the port 5000, and the REST service running on the EC2 machine accepts the request through port 5000. It'll process the request, talk to the database, and send the response back to the client. At the moment, the server is running okay since the health status is good. Let's take a look at the REST service that's running on the EC2 machine. Let's see how to start the REST service, how to track the logs, how to send requests through the web pages to the REST service, how to get the responses and validate it. Here on the left pane, I have the web pages 1 and 2, one to check the check URL endpoint and the other one to check for the check URL endpoint for a bad URL. URL_svc has the source code for our REST service. And if I were to run this command through gUnicorn, it would start the REST service under port 5000. Now that the service is running, we can refresh the page here on the left pane, and it should provide us the results. As you can see, the endpoint to check the URL is here, and then the actual URL part is the last value here, and then it returned the results with URL, domain, hash value, and then whether it is a malicious URL or a good URL. Here the value is harvard.edu, and here on the right pane we can see the log messages of the REST service that's running. And we can also take a look at the other web page that has the check URL endpoint to check for a different URL. And if the URL is not available in the system, it'll send a response saying URL is not available. The system runs using base64 value, so we would have to give base64 value of the URL that you're trying to query in the endpoint it is a good idea to build a system using base64 because the traditional URLs or the URLs might have special characters that might limit the functionality through a web page. We can also run the same commands through curl and get the results. As you can see on the right pane here in the right window, meaning the same endpoint through curl command, and I have gotten the results. Essentially, your curl is another way of executing the same endpoint. It's just that it is through terminal. I have set up the Postman tool. This is a third-party client that you could use to send requests to the endpoint. And here, if I were to run the endpoint, let's see here. If I were to hit send here, we'll see the response here, trace, and then the response here in the down pane. As you can see, we got the logs and then also the response in the Postman tool. So as we have seen, we can use check URL endpoint and check domain endpoint to query the system. Check URL specifically queries the system using a URL, and check domain will also run the queries against the database. And interestingly here, the check domain can also be used to retrieve all the URLs that are associated with a single domain. Like we have seen, this specific domain has 4 URLs linked to it, and all of them are malicious. That concludes the presentation of the project. If you have any questions, please reach out. Thank you.